Okay, here are the polynomial inequality notes, page 2. We've got steps along the left-hand side. We're going to do what we did up above. So this would be a good time to hit pause, come back, and double check. Okay. So I'm going to start by factoring this. I'm going to factor the x out of both. Leaves me with an x squared minus 1. I get x times x plus 1 times x minus 1. I want where this is greater than 0. That means my critical values, where this is changing direction, are at 0, 1, and negative 1. Okay. Nice big super long number line to cram everything in like that. So now we have to check the different parts of our x-axis. Okay, I'm going to plug in -2, and I'm going to use, again, I'm going to use the factored form. So with x equals 2, my x times x plus 1 times x minus 1 becomes 2 times 2 plus 1 times 2 minus 1, 2 times 3 times 1, which is positive 6. It's positive over here. Okay. If I check between -1 and 0, we are going to move all of this over here, because I obviously plugged in positive 2, means this part is positive, and we shall erase any record of me babbling on incoherently. Okay, let's try x equals positive 1/2. Now, because I'm using the fractions, this part's positive, this part's positive, and this part's going to be negative. I got a positive times a positive times a negative. It's negative in this little interval. Okay. So let's do the same thing with -1/2. I get -1/2 times -1/2 plus 1 times -1/2 minus 1. This is negative. This is positive. This is negative. A negative times a negative gives me a positive. So I know this little interval right here is positive. And because I know the way that this cubic should look, x equals -2, I get -2 plus 1 times -2 minus 1, -2 times -1 times -3, -2 times -1 is positive 2 times -3 is -6. So all over here, it's negative. Because we want this strictly greater than 0, I cannot include the endpoints of those intervals. Greater than 0 means I want where this is positive. So this is positive between -1 and 0, again, parentheses on both sides, and from 1 to infinity. And there's our solutions. Example 4, we don't have an inequality, so let's go less than or equal to 0 so we get the chance to include those endpoints. This is a quartic, so I'm going to start by factoring in terms of x squareds, because this I can factor further. So I've got critical values at x equals 3, x equals -3, x equals 1, and x equals -1. Because this is less than or equal to 0, I am going to include those endpoints. And so I'm putting those here as closed dots, not the open circles we had above. I am going to go ahead and start with x equals 0. Because that's in this middle interval, and 0 is easy to use. I got 0 minus 3, 0 plus 3, 0 minus 1, 0 plus 1. I could have really just gone to the original, because we should get 9, right? So it's positive between -1 and 1. It's 0 at those endpoints, the -1 and 1. Again, that's why we've got them represented as closed circles. So let's go with -2. I get -2 minus 3, -2 plus 3, -2 minus 1, and -2 plus 1. Really, I only care whether each of these values is positive or negative. Sometimes students aren't super comfortable with that and they want the actual numbers. I get -5 times 1 is -5 times 3 is positive 15 times 1 is -15. So I am negative between -3 and -1. Let's see what happens over here between 1 and 3. When x equals 2. I get 2 minus 3, which is -1, 2 plus 3, which is 5, 2 minus 1, which is 1, and 2 plus 1, which is 3. I get -15 here as well. Last thing I have to do is check those outer intervals. So let's go with x equals -4. -4 minus 3 is -7. -4 plus 3 is -1. -4 minus 1 is -5. And -4 plus 1 is -3. We are getting big numbers. I get +7 times +15. I know my answer is going to be positive. If it's important to you, you can still multiply out and get 105. And our last chunk, just so we're sure, x equals +4. 4 minus 3 is 1. 4 plus 3 is 7. 4 minus 1 is 3. 4 plus 1 is 5. These are all positive. We're getting a positive 105. So everything in this interval here is positive. We are looking for solutions. By solutions, I mean the x's that give us negative y's. That's our less than or equal to 0 part. So our solutions here are the intervals from -3 to -1. We are including those endpoints because it can be 0, and +1 to +3. All of the x's that give us negative y's.